Now we want to know what is the difference between weak and strong acids and bases. We know now the acids they give more hydronium ion when they split or break apart to give more hydronium ion, but for bases they give more what hydroxide ion. Actually, some acids they are very strong. They are corrosive. Acids and base they are corrosive. They might burn skin or eyes. But some acids that like the acid that you find in the food, okay, they are not dangerous. Yani if you put it on your hand, it will not burn your skin. Now, what is the thing that determine if the acid or base is strong or not? This one is determined by the ability or the strength of an acid or base depends on percentage of its particles that break apart to form ion in a solution. So again, what is the thing that determine the strength of an acid or base? It depends on how many ions are or it releases into the solution. This part is very important. Okay, so that means some acids are strong, some acids are weak. Some bases are as strong, some bases are weak. What are the things that help us, or what are the examples? I want to show you this example here. Example of a strong acid is hydrochloric acid, which is HCl. For HCl, when you dissolve it in water, all of it will break and give what? More hydronium ion. So look at this beaker number 1. Hydrochloric acid is what? Is a strong acid. The green sphere represent HCl, okay? The red one represent here red with the blue, with the 3 blue spheres, a hydronium ion. The one look here, so which means for hydrochloric acid, all hydrochloric acid they will split and give what? H. So all the here water it will form H3O plus hydronium ion. Example of weak acid, acetic acid. Acetic acid you can find it in vinegar. It has another name, it's called ethanoic acid. Actually for acetic acid I'll give you another formula, it's easier for you, which is CH3 COOH. This one acetic acid is what? Is weak acid. How it's weak? It will give less hydronium ion. Here the purple sphere represent what? Represent CH2, this one here with the blue represent CH3 sorry, COO negative. Look here how many one? This is the first one, the second one, the third one. One of them split and give what? And give hydrogen to water to form a hydronium ion. And okay, so that means number of hydronium ion in weak acid less than in a strong acid. Here hydrochloric acid completely split, okay, but break apart, but here not all of it will break apart or give a lot of hydronium ion. Okay, what about bases? Bases the same thing. We have strong bases and we have weak bases. For strong bases example, NaOH. This molecule here represent Na. This one let's go say it's pink, and this one red sphere, and this sphere is blue. This here represent OH and this one represent Na. For strong, all of it will break apart to give what? Hydroxide ion. Look how many hydroxide ion? 1, 2, 3, 4, and here Na plus, Na plus. So completely break apart. But look at weak base. Weak base example. example, NH3. NH3, it doesn't contain OH, but instead it has the ability to what? To take hydrogen from water to form hydroxide. But look at number of hydroxide are formed here. Only one. Here you have in the other hand you have NaOH. It gives 1, 2, 3, 4 hydroxide. So the ammonia is weak base, but sodium hydroxide is strong base. So also I want you to put in your mind something. For the strength of an acid or base is not the same as its concentration. What does that mean? We said hydrochloric acid, it's a strong acid, okay? And it might damage the skin. But for hydrochloric acid, and if you put water, you add more water and you make it like dilute hydrochloric acid, it has the ability to what? To damage your skin, because all the hydrochloric acid, they will split apart or break apart to give hydronium. The same, but what about the weak? The weak, for example, is citric acid, does not harm your skin. Even if you have concentrated low amount or a sample of citric acid, still it doesn't harm your skin, because not all citric acid it will give give what? Hydronium ion. It will not give a lot of hydronium ion. So the strength, it depends how many hydronium ion for the acid, for sure it will give. If it's a lot, it means it's strong. The same thing for bases. If it gives a lot of hydroxide, it means it's strong. But for weak bases or acids, they give less amount of ions. To make sure that you understand the lesson, I want you to solve, it's a homework, a question 10 on page 280. Also watch this video. While you're watching this video, please take notes.
Acids and bases may be strong or weak. Weak acids and bases produce fewer ions when dissolved in water than strong acids and bases do. Click the images to learn more about acid and base strength. When weak acids dissolve in water, only some of the molecules break apart and form hydronium ions. Most of the acid does not form ions. When a weak acid, such as acetic acid or vinegar, is added to water, most of the acid molecules stay intact. Only a few hydronium ions form in solution. Strong acids form more hydronium ions when they're dissolved in water. A strong acid, such as hydrochloric acid, completely breaks apart when it dissolves in water, forming many hydronium ions in solution. When weak bases are dissolved in water, only some of the molecules form hydroxide ions. Most weak bases don't actually contain hydroxide ions. Instead, they're proton acceptors. For example, when ammonia, a weak base, is added to water, some of the molecules accept a hydrogen ion, or proton, from water. When a water molecule gives up a proton, what's left is a hydroxide ion. A strong base forms many hydroxide ions when it's dissolved in water. Unlike weak bases, strong bases often contain hydroxide ions that break off when they're added to water. All of the sodium hydroxide, or Li, molecules break apart when dissolved in water. The strength of an acid or a base does not depend on its concentration. Strong acids or bases can be concentrated or dilute. The difference is the number of ions that form in solution. A strong acid or base will form more ions in solution, as hydrochloric acid does on the right, than the same number of molecules of a weak acid or base. In other words, the ratio of molecules that break apart in water to the number of molecules that don't describes the strength of the acid or base.
Please don't forget to send your answers to my email as Word document. If you have any question, you can send it to the group and I'll answer you. Thank you for listening.